In these examples, we're going to be converting between radicals and rational expressions just for some practice in notation. So if I have 13 raised to the 1/2 power, what that indicates is the square root of 13 to the 1st power. So remember, the denominator is always the root. 6 to the 3/4 power means the 4th root of 6 cubed, or the 4th root of 6 cubed. Doesn't matter which way you write it. C, we have 9m to the 5/8. Be careful here. The only thing that the 5/8 belongs to is that m. So the 9 is just out front, and it's going to be times the 8th root of m to the 5th. So that is just the way you want to write it, because again, the fractional exponent only belongs to the m. Here we have a negative exponent, so we know it means 1 over r to the 2/3, and you're fine to leave it just like that. But if you wanted to write it, oh, I think it said write each radical as an exponential and each exponential as a radical, so we do need to change that. That would be 1 over the 3rd root of r squared. The next one is a dangerous one. You've got to be careful of this one. What this means is the square root of a squared plus b squared. Don't think anyone will have trouble with that. You know that this is the root. But what you have to understand is that that does not equal a plus b. Because of the plus sign there, I can't split those and take the square root of those separately. Because if it did equal a plus b, let me show you something on another sheet of paper. If it did equal a plus b, then I would be able to take a plus b and square it, and supposedly I would get a squared plus b squared. Well, let's do that. A plus b squared means a plus b times a plus b. If we now FOIL that, a squared plus ab plus another ab, or ba, same thing, plus b squared, I get a squared plus 2ab plus b squared. I don't get a squared plus b squared. And that is because a plus b squared does not equal a squared plus b squared. So you want to be very, very careful with this. Don't go further. It does not split apart and allow you to take the square root of each of those separately. If that had been a multiplication sign, then you could have split it, but with a plus sign you can't. It's a unit. Square root of 10 is the same thing as 10 to the 1/2 power. 4th root of 3 to the 8th. Our base is 3. Here is our root. That is your denominator. The 8 goes up here, but that simplifies. 8/4 is the same thing as 2, and 3 squared is the same thing as 9. On this one, my base is z. Here is my root. My numerator is the same, which is just z to the 1st, or just z. And by the way, as a generalization, assuming that all variables are positive, real numbers, if what I'm raising my base to is the same as my index, it will always just equal what's underneath. All right, let's look at example 2. It says write with only positive exponents. Assume that all variables represent positive real numbers. So we're going to go back again to some of our exponent rules where we are here multiplying like bases. So that means I have to add my exponents. So I have to add 1/2 plus 1/4. Well, in order to add 1/2 and 1/4, I have to have a common denominator. So it's the same as adding 2/4 plus 1/4. So I'm going to rewrite it as 2 to the 2/4 times 2 to the 1/4, which is 2 to the 3/4. So yes, you might have to do things with fractions like finding a GCF, etc., or a common denominator, an LCD. You may have to do that when those fractions are exponents. So not only are you applying the rules for exponents, you're applying the rules for fractions. So you really have to be careful with these. Here I see an example of the exponent rule where when I'm dividing like bases, I subtract my exponents. So this is going to become 5 to the 2/3 minus 7/3. Now they already have a common denominator. So that is 5 to the negative 5/3. Now it says to leave it with only a positive exponent, so I know that that's 1 over 5 to the positive 5/3, like that. These next two take quite a bit of work. So let's look at this one. I have x to the 1/2, y to the 2/3. That's my numerator, and it alone is being raised to the 4th power, and that is all over y. So we know that inside-outside exponents are the power rule, and I have to multiply. So I'm going to think of this as 4 over 1. So it's going to be x to the 1/2 times 4 over 1. So 1/2 times 4 over 1 right there. I can cross cancel just like I always do, and I get x to the 2 over 1. Now I have y to the 2/3 times 4 over 1. Here I can't cross cancel, so that's going to be y to the 8/3, and that is all over y. Now you may think you are finished, but if you have like bases in a numerator and denominator, you are not finished. And it's because I can do what I did here. I can apply the rule, the quotient rule that says I can subtract those exponents. So it's going to be 8/3 take away y to the 1. Well, 1 is the same as 3/3. So what we're going to say is that we have x squared, and then we have y to the 8/3, it's hard to write this small, minus 3/3, which gives me x squared y to the 5/3. Now, both of those are positive exponents, but you had to apply a lot of the different exponent rules here along with understanding how fractions work to be able to do this. So you've really got to be careful. Let's look at D. This one is different than C in that the exponent on the outside applies to the entire fraction. When that is the case, you always want to simplify what is inside first. So what I have is x to the 4th. It's happy where it is. X to the negative 2, it's a negative exponent, so my base has to move, so that comes up and joins that x. My y to the negative 6, it's unhappy, it comes down here. Y to the 1/3 stays where it is. All of this is going to be raised to the negative 2/3 once I get simplified inside. The numerator is fairly easy. X to the 4th, x squared is x to the 6th. But in my denominator, in order to add my exponents, I'm going to have to find a common denominator. 6 over 1, 1/3. Well, that common denominator of 6 over 1 and 1/3 is 3. So it's 18/3 plus 1/3 is 19/3. So it's x to the 6th over y to the 19/3, and now I'm ready to apply this negative exponent, negative 2/3. So we're not finished yet. So now I'm going to apply the negative piece of that exponent, meaning use the reciprocal. So I end up with y to the 19/3 over x to the 6th, and all of that is now to the positive 2/3. So we're still not finished. Outside exponents indicate multiplication, so that's going to give us y to the 38/9 over, this is going to be x to the 6 over 1 times 2/3. thirds, I can cross cancel, x to the fourth. That was a difficult problem because of all the things you had to be aware of in that problem. Let's look at this last one, and I hope that when you look at this you think, oh, distributive property. So when I distribute bases that have exponents and my bases are alike, I add the exponents. So it's going to be m to the 3/4 plus 5/4 minus, distribute here, m to the 3/4 plus 1/4. Or m to the 8/4 minus m to the 4/4, which is just m squared minus m. These are tricky. You're probably going to want to go find some more and practice them.